Okay, guys, so here is more inverse trig derivatives. So last video we did inverse sine, inverse secant, inverse tangent. And guys, if you know these formulas, then you know these formulas also, because these are just going to be, the derivatives of these are just the negatives of the derivatives of these. So these are called cofunctions. They have a relationship, a special relationship. So cosine and sine are cofunctions. Cosecant and secant are cofunctions. And cotangent and tangent are cofunctions. And there's a few things that happens with cofunctions, but a big one is that sine of one angle equals the cosine of the complement of the original. So you might remember this from in geometry. This was kind of a big deal. So if you had sine of theta, that was the same as cosine of 90 minus theta. Okay, because complementary angles add up to 90 degrees. Oh, here was another thing that we would do. So yeah, like if this was theta and that was 90 minus theta. So the sine of this angle was equal to the cosine of that angle. So that's why you call them cofunctions, so complementary cofunctions. Starts with CO. Alrighty. So yeah. So guys, the derivative of inverse cosine, if you know the derivative of inverse sine, instead of a 1, it's a negative 1 over. The negative could also go out front of the fraction or up top. So if you know the derivative of inverse secant, then the derivative of inverse cosecant is just the negative of that. And if you know the derivative of inverse tangent, the derivative of inverse cotangent is that. Okay, so let's just do two little examples. Oh, these are from the practice, by the way. So this is number 2 from the practice. This is number 12 from the practice. I forgot to say last time that these were from the practice. So that's number 2 from the practice, number 12 from the practice, number 30 from the practice. I don't need chain rule, so I can just go right to the derivative. I bring down the coefficient. The derivative of inverse cosine is this. All right, and then I can simplify if I want to. So as far as simplifying goes, guys, I would say if it's easy to do and you feel like doing it, then do it. If you're confident you're not going to make any mistakes and it's like not going to take a long time. This is pretty unsatisfying to me to leave it like this, so I simplified. All right, now this next one, we are going to need chain rule because it's not just a regular x that's inside the cosecant, it's a 12x. So inside, outside, the derivative of the inside is 12. The derivative of this outside is negative 1 over, negative 1 over absolute value of blank, radical blank squared minus 1. And then what goes back in the blanks is the 12x. So y prime, negative 12. Okay, so there's that, guys.